Hello everyone, in this video we will explore how to find the area under a curve using numerical integration methods, specifically the trapezoidal rule and Simpson's rule. As we all know that integration helps us to find area under the curve, volumes and many more. But what if we can't integrate the function exactly? These techniques like trapezoidal and Simpson's 1/3 and 3/8 rule are useful when we can't integrate the function easily or when we have experimental data instead of formula. Some functions like e to the power x square. These are some of the functions which can be integrated easily. So we'll use trapezoidal and Simpson's rule for this. So we know that the area bounded by a curve f of x can be written as I equals to integration of a to b f of x dx. Let this be equation 1, and that we can draw this curve as like this, where a and b are the upper and the lower limits. So how do we solve this? So to solve this by numerical analysis, we divide the interval a comma b into n equal intervals. So we'll divide it into n equal intervals with length h. You can also call this h as step size. So we'll divide this upper and lower limit in h. So suppose we have a upper and lower limit as a, b. So we divide it in n intervals. So it will look like this. A will be x0, and we'll have x1, x2, up to xn, which will be equals to b. Here we can write n is equals to b minus a by h, where h is the length of the interval. After dividing, the function is going to look like this. This one will be x0, x1, x2, x3, and this one will be xn, y0, y1, y2, y3, and then yn. So this length here will be h. So we can also write it as e is equals to x0, and then x1 is equals to x0 plus h, x2 equals to x1 plus h, and then up to xn, which will equals to xn minus 1 plus h. Now let's see the different methods for integration. So the first method we have is trapezoidal rule. The trapezoidal rule can be written as h by 2. H is length, and then the first term plus last term plus 2 times of the remaining terms. Trapezoidal rule can be written as this. This is applicable for any number of intervals. Let me write it down here. It is applicable for any number of intervals. Let's go to the second formula. Second formula we have here is Simpson's 1/3 rule. And this formula is specifically used for even intervals, meaning that n should be always even. Formula goes h by 3, the first term plus last term plus 4 times the, here we'll write the odd elements, that is like y1 plus y3 plus y6 will come, not y6, sorry, y5, and then plus 2 times all the even intervals will come here, y2 plus y4 plus. So this is applicable only if the total number of intervals is even. Next we have Simpson's 3/8 rule. First term and the last term plus 3 terms, you give a gap here for now, and then plus you write 2 times all the multiple of 3, that is like y3, y6, and then y12, all this will come here, and then here will be that remaining term, that is y1 plus y2 plus y4. So this will be multiple of 3. So you can remember all this formula in this way. Always remember that if no intervals given in the question, we can take it as 6, so that we can use all these 3 formulas. So now let's do a question. We'll do a question, okay? So evaluate using trapezoidal, Simpsons 1/3, Simpsons 3/8 rule. So let's see the question. Here we have y is equals to 1 upon 1 plus x squared dx. We need to integrate this. So let's start. Here we are not given the number of intervals, so we'll take it as 6, so that we'll be able to do it with all the 3 formulas. So we all know that n is equals to b minus a upon h, and b is this one 0, and then b will be 1, and then a will be 0. So we'll have here 1 minus 0 upon h will be, we have 6. Sorry, this one will be n, and this one will be h. So we'll get here 1 by 6. So now we'll have our x0 as starting from 0, and our x1 will be x0 plus, what is our h? Here we have 1 by 6. So we'll get here 1 by 6. Then our x2 will be 2 by 6. Our x3 will be 3 by 6. x4, 4 by 6. Now x5 is 5 by 6. And our x6 is 6 by 6, that is 1. So we have already divided the intervals here. Now as we know that y is equal to 1 upon 1 plus x squared, we'll put a value of x in this formula. So y0 will have 1 upon 1 plus x0 square, we'll get here 1. And our y1 will be equals to 1 upon 1 plus x1 squared, that is equals to 1 upon 1 plus 1 by 6, so we'll get 1 by 36, which will equals to 36 by 37. And our y2 here will be 1 upon 1 plus x2 squared, which is equals to 1 upon 1 plus, we are 2 by 6, so it's actually 1 by 3, so we can write here as 1 by 9, which will give us 0.9. Our y3 as 1 upon 1 plus 1 by 4, which will give us 0.8. y4 we have 1 upon 1 plus 4 by 9, It is 9 by 13. Our y5 here is 1 upon 1 plus 25 by 36, which we'll get here as 36 upon 61, and y6 here is 1 upon 1 plus 1 square, which we'll get is 0.5. So we have got all our values. Now what we need to do is we just need to put this in our formula. First one we'll do is by trapezoidal rule. Trapezoidal rule. So integration of 1 upon 1 plus x square dx. We know that the formula is h by 2, first term and the last term. So the first term here is y0, and the last term here is y6, and then plus 2 times of the remaining terms, that is y1 plus y2 plus y3 plus y4 plus y5. So putting the values here, we'll get each we have 1 by 6, so we'll get 1 by 6 by 2. y0 we have 1 plus, then y6 we have 0.5 plus 2 times of y1. So y1 we have here is 36 by 37. 36 by 37. y2 we got 0.9. y3 we got 0.8. or y4 we get 9 by 13, and our y5 we get here is 36 by 61. So solving all this, we'll get our answer to be approximately 0.78539 and 6. Now let's do with another formula, that is by Simpson's 1/3 rule. So we'll do now by Simpson's 1/3 rule. Now let's do it. So we have here 1 plus x square dx. So we know the formula is h by 3. There's the first term, that is y0, plus the last term, that is y6. Those 4 terms times the odd terms. The odd terms that are like y1, y3, and then we have y5, plus the even terms, 2 times the even terms. The even terms we have here is y2. We can't write y6 because we already got y6 here. So now let's put all the values here. H we've got 1 by 6. And y0 we've got 1, and then our y by 6 we've got 0.5. Plus 4 times y1 we've got 36 upon 37. Our y3 we've got 0.8, and then our y5 we've got 36 upon 61, plus 2 times of y2, which is 0.9. So solving all this, we'll get its value approximate to 0.785396. Now by the last formula, that is by Simpson's 3 by 8 rule. We get it as 3 into h by 8. The first term and the last term, that is y0 plus y6, plus 3 terms, just leave for it for now, and then 2 times the multiple of 3. So the multiple of 3 we have left here is y3 only. And the remaining terms will come here, that is y1 plus y2 plus y4 and then y5. So that's all we got. Now let's put the values in here. 3 times of h we've got here is 1 by 6 upon 8. Our y0 we got here is 1. y6 we've got here is 0.5. 3 times of all the remaining terms, that is. Our y1 we got here 36 by 37 plus y2 here is 0.9 plus y4 here is 9 by 13, and our y5 here is 36 upon 61 plus 2 times of we have our y3, which is 0.8. So putting all the values, solving all this, we'll get the value to be approximately 0.785394. So that's all. This is how you solve. Just need to remember the formulas, and always remember that take the interval to be 6 if it's not given in the question. So today we have done how we use these formulas and what numerical integration is. This numerical integration, we just divide all the curve into some smaller segments with length h, with width h. That's what we do, and then we integrate all those parts. This is what numerical integration is. So thank you and have a great day.